Although called the Age of Reptiles, the first period of the Mesozoic Era, the Triassic, did not start out that way. The dominant animals were initially Synapsids, the proto-mammals, who had been the most common large animals during the preceding Permian period. At the start of the early Triassic, the synapsid Lystrosaurus was famously the most abundant animal, and by a wide margin. However, it didn't take long for the synapsids to be pushed to the margins by reptiles, and only mammals and a few other tiny cynodonts remained at the dawn of the Jurassic period. Still, a few large synapsids persisted into the late Triassic. Among the most famous is Placerias, who lived in North America between 230 to 220 million years ago. Even though Synapsida as a whole was on the decline, Placerias weighed over a ton, making it the largest herbivore in its environment. Placerias was a member of Dicynodontia, the same clade as Lystrosaurus. It was not its direct descendant, but belonged to the closely related Dicynodont subclade Canamaeriformes, whose members were also large herbivores. Like most other Canamaeriforms, Placerias's legs were held in a semi-erect stance. Combined with its rotund body, Placerias would have been slow compared to the other Triassic megafauna. Perhaps the most eye-catching Dicynodont trait was their beaks. They were toothless, except for a single pair of teeth, which were usually long and tusk-like. By Dicynodont standards, Canamaeriform beaks were relatively long and pointed, which is thought to have been an adaptation for browsing higher foliage than their Permian ancestors. Placerias's lower jaw was less robust than those of most of its relatives, suggesting it consumed softer flora, although its bite force would still have been quite formidable. The back of its skull was short but raised high. Combined with its beak, Placerias would have looked almost like a mammalian ceratopsian if its crest hadn't been obscured by its powerful neck muscles. Like many other Canamaeriform Dicynodonts, the skull bones behind its orbits had a rugose texture, but those of Placerias are distinct for their deep furrows. Unlike the tusks of most other Dicynodonts, which were usually the remaining pair of teeth, those of Placerias and some other Dicynodonts were instead extensions of the maxilla. The teeth themselves had become much smaller, and those of some Placerias individuals were located in atypical positions or did not even erupt from the bone at all. It appears even fairly dramatic mutations no longer affected their fitness, suggesting the teeth were vestigial. As for their replacements, they are thought to have been covered with a keratinous sheath, much like horns often are. While they face forwards in walking with dinosaurs, the real tusks actually faced downwards. It has been suggested that they were used for digging up roots, but Placerias is thought to have used its tusks in battles against each other in contests over mates. As will be elaborated later on, the tusks of female Placerias seem to have been smaller than those of the males. The first Placerias fossil, a large humerus, was found in 1900, and it was formally named and described in 1904. Although not very impressive, many more Placerias fossils have been found since then. Most come from a single site in Arizona, appropriately dubbed the Placerias Quarry. Altogether, fossils belonging to at least 41 individuals of this giant Dicynodont have been excavated there. However, although Placerias's postcranial anatomy is fairly well understood, none of the skeletons are complete. The Placerias skeletons seen in museums are either casts or composites made from several individuals. Indeed, the most complete skull was not even found in the quarry. It is far from complete itself, but its discovery did at least confirm the disarticulated composites had been put together correctly. The Placerias Quarry is a part of the well-studied Chinle Formation, but Placerias fossils are rare throughout the rest of the formation. It has also been found in the contemporaneous Pekin Formation in the eastern United States, suggesting this ancient stem mammal was once fairly widespread. Currently, there is only one recognized species of Placerias, Placerias hasternus. A second species, Placerias gigas, was named in 1956, but the supposed differences between the fossils are now thought to have merely been the result of distortion after fossilization. Some Moroccan Dicynodont fossils were previously assigned to Placerias, but they have since been given their own genus, Mocreberia. The Placerias fossils found at the quarry are divided into two different morphs, one smaller and one larger, the latter of which also has longer tusks. These traits cluster with each other consistently, and each morph is about as common as the other, so their differences cannot simply be the result of individual variation. As was hinted at earlier, the leading hypothesis is that the two morphs are males and females. Among species who engage in contests to compete for mates, either violently or through purely visual display, males often have a greater body size and more elaborate display structures like horns, crests, or tusks. This perfectly matches the pattern seen in Placerias. A prior hypothesis was that the smaller morph were those Placerias who were not yet fully grown, but examination of their bone histology found all Placerias at the Placerias quarry were adults. The smaller morph had a slower growth rate than the larger one, which could have been the result of developmental plasticity, meaning the smaller morph consisted of Placerias whose growth had been stunted due to a food shortage, likely the consequence of the droughts common to the Triassic period. Finally, the two Placerias morphs could instead represent two different species. Since their fossils are disarticulated, it wouldn't be hard for two closely related Dicynodont taxa to have been accidentally mistaken for a single species. Furthermore, as will be elaborated on later, Placerias did coexist with at least two other species of Dicynodonts. However, none of the fossils from the Placerias quarry match those of the other taxa, and given the conveniently equal frequency between the two morphs, the sexual dimorphism hypothesis remains the best explanation. Placerias and the other Triassic Dicynodonts have sometimes been envisioned as semi-aquatic hippopotamus analogues. While this might have been true for some species, it is unlikely to have been the case for Placerias. Even though the layer of the Placerias quarry, which contains its namesake, seems to have once been a pond, the rest of the fauna preserved alongside the Placerias fossils are primarily terrestrial creatures. It seems the animals congregated around this pond during the dry season, where they perished before the rains returned. Like the other late Triassic Connemaieriforms, Placerias's pointed beak and the orientation of its skull were specialized for browsing higher-level vegetation, like tree branches. Therefore, it appears to have been primarily an inhabitant of forests rather than swamps. It should be no great surprise that the last large Triassic synapsids were restricted to such dense environments, as their semi-erect gaits would have made it difficult for them to outrun the increasingly dominant archosaurian predators such as Postosuchus, who had fully erect gaits. While they are not the only creatures whose remains have been found at the quarry, the overwhelming abundance of Placerias at the site has been used to support the idea that they lived together in herds. However, it is possible this is instead the result of preservation bias. Due to their size and robustness, Placerias bones would have been fossilized at a disproportionate rate. In its appearance in the first episode of Walking with Dinosaurs, Placerias was portrayed as an evolutionary relic on the verge of extinction. This was part of a larger narrative in the episode, characterizing the rise of the dinosaurs as them outcompeting the preceding fauna due to their innate superiority. In many ways, this picture is pretty outdated. The dinosaurs' ascendancy is now attributed less to them outcompeting their predecessors and more to mere opportunism following the demise of all other large to medium-sized animals during the end Triassic mass extinction, a disaster which struck 20 million years after Placerias. However, the depiction of Placerias itself as on its last legs, evolutionarily speaking, otherwise still reflected the scientific consensus until just a few years ago. It was the last known Dicynodont, and with the exception of the Placerias quarry, its fossils are uncommon in spite of the fact that the Chinle Formation is very well sampled. Today, Placerias is viewed quite differently. For starters, the Placerias quarry is atypical of other contemporaneous Chinle Formation sites because of its more terrestrial fauna. The sparsity of fossils belonging to this giant Dicynodont is likely a consequence of preservation bias rather than an indication of genuine rarity. More importantly, Placerias was not the only Dicynodont present in its native environment. In 2013, after a century of debate, it was finally determined that Dicynodont fossils from the contemporaneous Popo-Agi Formation of Wyoming belonged to a distinct genus, Eubrachiosaurus. Additionally, some Dicynodont femurs from both the Eastern Pekin Formation and the Western Santa Rosa Formation have markedly different morphologies from both Placerias and each other. One of these may belong to Eubrachiosaurus, but in any event, Placerias coexisted with a minimum of 2 other Dicynodonts. Until recently, it was thought that each late Triassic environment was home to no more than a single species of Dicynodont. Far from being on their last legs, it is now apparent that the Connemyeriforms were still doing well during Placerias' time, albeit not as well as during the Permian and the first half of the Triassic period. Furthermore, in stark contrast to the old perception of Placerias just barely clinging on, it appears to have been very long-lasting. The Placerias quarry is dated to 219.4 million years ago, during the early Norian age, whereas the fossils from the Pekin Formation are 231 million years old, dating to the late Carnian age. 10 million years is longer than most dinosaur genera lasted. It should be noted that even though Placerias is often portrayed as a contemporary of the archetypal early dinosaur Coelophysis, its fossils belong to a different stratigraphic unit of the Chinle Formation, and Coelophysis lived at least several million years after Placerias' presumed extinction. But even if Coelophysis wasn't neighbors with Placerias, it still shared a world with other Dicynodonts. A Dicynodont from late Norian South Africa, Pentosaurus, was named in 2018. It notably coexisted with large sauropodomorph dinosaurs, who had previously been attributed with the demise of Dicynodontia. In the following year, the discovery of another late surviving Dicynodont was announced. Named Lizowickia, it lived in what is now Poland at the very end of the Triassic period. Although Placerias was the largest herbivore in the American Southwest, it was dwarfed by the 6-ton Lizowickia, who was about the same size as an African elephant. Unlike Placerias, Lizowickia's limbs were erect like those of mammals, an adaptation it developed independently from them to support its greater mass. Although Dicynodonts were not as common or diverse as before, Lizowickia demonstrates that these stem mammals didn't just manage to stick around, but were innovating in surprising and dramatic ways up to the very end of the Triassic period. In all likelihood, the last Dicynodonts perished along with the rest of the non-dinosaurian megafauna during the end Triassic mass extinction, which was caused by a period of extensive volcanic activity. The devastation ranged from the acidification of the oceans to long-term global warming, which was punctuated by potentially decade-long volcanic winters. Therefore, the Dicynodonts only died out due to a cataclysm they could have never prepared for. In this light, Placerias should not be seen as the last gasp of antiquated Permian holdovers, but as an example of the success of Synapsida.
Thank you to themattalorian for narrating this video, and a thank you to all of you for helping this channel reach over 50,000 subscribers. I hope you enjoyed this video and learned from it. If you did, please remember to hit the like button, and if you have not yet subscribed, be sure to do so if you would like to see more. Finally, be sure to have a great day.